Hi everyone! We're here at NASA's Goddard Space Flight Center in Maryland to talk about the total solar eclipse happening in the US just under a year from today. There's tons of information on our website, eclipse2017.nasa.gov. In just a second, we're going to talk to a few NASA scientists who study the sun to learn about how to watch an eclipse, what our scientists hope to learn, and why we even study the sun at all. We'll also be answering your questions throughout the show, so put those down in the comments section and we'll get to them a little bit later on. My name is Sarah Fraser and I'm a science writer here at NASA. I'm going to start by talking with Lika Guhatakorta, one of our NASA scientists. Hi, Lika.
Hi, Sarah.
Can you tell me a little bit about what you study?
Well, I'm an astrophysicist. I was trained as one. In my graduate school, I studied just one star at the exclusion of all others, and that's our sun. And I think that's the only one that counts. And then as my research career progressed, I actually studied the outermost atmosphere of the sun, the solar corona, which is what we see during a total solar eclipse. And today, I am a heliophysics discipline scientist at NASA headquarters, really trying to understand and manage the variability of the sun, the mood swings that it goes through, and its impact on our planet, other planets, and astronaut safety.
Great. So I'll hand you this microphone, and why don't you take us through what we're seeing on this screen right here?
Sure. So what you're looking at here is the continental map of USA, and this bright kind of reddish-orange patch, white patch that you see is actually the shadow of the moon. It is the penumbra. The wider range that you're seeing is this is the umbra, and the rest are penumbra. And it is in this patch that you are going to be able to see a total solar eclipse when the entire bright disk of the sun is going to be covered by the moon. And this goes sort of coast to coast, from west coast of Oregon all the way to South Carolina, crossing over 12 states within easy driving distance for at least 100 million people with 100 or more universities and colleges. It's a great opportunity. And I think this is going to be one of the most observed, filmed and photographed, studied and documented, and most appreciated eclipse in the human history. And everyone who can should go try to see this totality.
Great, thank you. I can't wait. So if an eclipse happens when the moon passes in front of the sun, why don't we see one every single month?
What a great question. The short answer is physics, celestial mechanics, math. So what happens is that the plane in which the Earth goes around the sun, called the ecliptic plane, is not the same as the plane in which the moon goes around the Earth. It's offset by about 5 degrees. These two planes have to coincide for us to see whether a total solar eclipse or a solar eclipse or a lunar eclipse. And to paraphrase my friend Neil deGrasse Tyson, there is no science like physics. It is the laws of physics that allow us to precisely answer the question, when is the sun going to rise? When is the eclipse going to begin? When is the eclipse going to end? So this 2017 eclipse provides us with that opportunity to really celebrate science, physics, and really broadcast it as widely as we can and share it with the general public.
Great. So I know you have seen a few eclipses. Can you tell us a little bit about what it's like to watch one?
Yes, I have seen 9 eclipses. Some I actually have seen them, and some were cloudy. Those are some of the chances that happens. I think eclipses, total solar eclipse, is widely regarded as one of the most awe-inspiring, breathtaking natural phenomenon that you can observe from our planet. This, to me, actually has the potential to be sort of life-changing, transformative experience. So again, as I said before, anyone who has the opportunity must make an effort to see this. Now, during the eclipse, you don't see kind of changes in the atmosphere in terms of light, ambient light, till we reach about 95% phase of totality, and you begin to see darkening and all of that. And it's really interesting that all creatures sort of respond to this fall in ambient light and changes in temperature, which can be up to 4 degrees Celsius, from grasshoppers to hippos, they all begin to behave in their natural instinct. For example, dragonflies will go hide under a leaf. So what happens is, as this phase continues and we get to 99%, you have the last few rays from the sun going through the valleys and mountains of the moon, and you begin to see Bailey's beads. And then you are left with just one ray, which produces this brilliant diamond ring effect. And when that diamond ring disappears, out comes this pearly halo, which is the solar corona. And you can't describe the luminosity of this corona simply because it's a very different phenomenon that gives rise to this light. It is the electrons around that actually scatter the sunlight. It has a very different glow, very different dynamics. Process continues, there is generally a lot of cheer in the beginning, then there is calm and quiet, and then the phase continues. You have the diamond ring, and you're out of the phase of totality. It's a great moment.
That sounds like quite an experience. Well, thank you so much, Lika. We'll be talking to Lika again in just a few minutes, but right now we're going to head outside and talk with Alex Young, another NASA scientist who's going to show us how you can safely watch the sun during the eclipse. In case you're just joining us, we're here at NASA Goddard in Maryland to talk about the total solar eclipse happening next August. There's lots of information on our website, eclipse2017, .nasa.gov. And we'll also be answering your questions, so leave those down in the comments section and we'll get to them in just a few minutes. So we're joining NASA scientist Alex Young to talk about how you can safely watch the eclipse without hurting your eyes. Hi, Alex.
Hi, Sarah. How you doing?
I am good. So why don't you tell us a little bit about what you study?
Okay, so I am an astrophysicist who studies the sun, often called a heliophysicist, and I study the activity on the sun, these huge explosions called solar flares, coronal mass ejections, things we generally call space weather, and how I'm interested in how they happen and how they impact the Earth.
So I understand you're going to take us through 3 different ways that you can watch the total solar eclipse. So why don't you start with the first one?
Okay, so let me take the mic here. I'm going to give you number 1. This is what we often call eclipse viewing glasses or solar viewing glasses. And this is glasses made of a special material. And what I want to emphasize here is, first and foremost, you should never look at the sun without the appropriate safety materials. Okay, that's very, very important. So we're going to talk about the first one, solar glasses. So you put those on while you're not looking at the sun. Okay, now you can turn around and look up at the sun, and you can see only the sun, nothing else. And sometimes you can even see sunspots if they're big enough on the sun. Pretty cool, huh? All right.
Yeah, very cool.
So that's number 1. So now let's look at number 2, something a little bit fancier, but a do-it-yourself kit. Okay, this is a pinhole viewing box. Take a box, something at least this big, preferably a little bit larger. Okay, you want to close it off completely, and then you want to cut 2 squares on the end. And over one of those squares, you want to put a piece of thick paper, or even better yet, aluminum foil, because you don't want any light to go through it. Then you take a thumbtack or a push pin, make a little hole. So now you've done that. So take this, point it down at the ground with the sun behind you so you can see your shadow in front of you. Then look through that open area and you'll see a little dot, and that is the sun projected onto the back.
Yeah, I see it.
Now, as your box gets bigger, you pick a bigger hole and you'll actually see a bigger sun projected on the back. But pretty nice way to do it. So that's number 2. So now let's go over here to number 3. This is what's called a sun spotter. And this is a fancy version of what we just had. This is a device that has a little couple of mirrors, and it has a lens, and you can see the sun projected onto the paper.
Oh,
So you see that?
Can I? So Alex here is a NASA scientist, and he's explaining to us what we're looking at. What is this little speck right here?
That is a sunspot.
So what are sunspots?
So sunspots are areas of intense magnetic field, and this is the area where solar explosions, solar flares, coronal mass ejections come from. This is the origin of space weather.
Awesome. Well, thank you so much for taking us through those different methods. And for those of you watching at home, there's lots of information about how you can safely watch the solar eclipse on our website, eclipse2017.nasa.gov. So now we're going to head back inside and answer a few of your questions. So I'm here at NASA with Alex Young, a solar scientist, and we're about to rejoin Lika, who we talked to a few minutes earlier. And they'll both be answering some of the questions that you've been leaving down in the comments. We'll also answer more questions a little bit later on, so keep leaving those for us. This is my colleague Lina, and she will take it from here.
Thanks, Sarah. Hey, my name is Lina Tran, and I'm another NASA science writer here in our heliophysics division. We've got your questions for our scientists, so let's get started. Alex, people are asking where can they buy these eclipse glasses?
Okay, so you want to go to our website to get more information. You can buy them in a couple of different vendors. NASA is going to be providing them to some people. So they're going to be all over in a lot of different ways. So look at our website and other Eclipse websites to find out how to get them.
Okay, cool. Lika, we have a question for you. Someone wants to know how wide is the path of totality, and also where's the best place on that path to view the eclipse?
The first one is easy to answer. The second one is going to be a little more complicated because this is going through such a broad length of the entire country. So it's about 100 miles in width, and it can't be much wider than that because of the geometry essentially. But where is the best place to observe it from? There is no one best place. The most important thing is you have to avoid cloud. And predicting that a year ahead is not very easy. Meteorologically speaking, we have looked at places and looked at, statistically speaking, what is the probability of cloudy forecast. And so we kind of take that into account. I know that a big chunk of NASA scientists will be present in the area of Carbondale, Illinois. But I think West Coast Oregon is a great place. It's going to be relatively early morning, like 10 a.m.-ish. Wyoming is a great place, low humidity up in the mountain. You can always be in the stratosphere on a plane, and that guarantees it. If you do, please let me know. I'd like to hitch a ride.
Okay, great. Thanks so much for your questions. Keep them coming because we're going to answer more later. But for now, Sarah is going to introduce us to another one of our NASA scientists.
Great, thank you. So we're headed to talk with Eric Christian, another NASA scientist. We're here at NASA Goddard in Maryland talking about the total solar eclipse happening in just under a year. There's lots of information on our website, eclipse2017.nasa.gov. So now we're going to talk with Eric Christian, a NASA scientist. Hi, Eric.
Hi, Sarah.
Can you tell us a little bit about what you study?
So I study energetic particles coming from the sun, but I've always been really interested in solar eclipses.
So I'm going to hand you this microphone. Can you tell us what we're looking at behind you?
Sure. So here you can see an image that shows the sun from one of our NASA satellites and two pictures from coronagraphs. Coronagraphs are how we make fake solar eclipses. We put a disk to block the main light of the sun, and then we can see the very dimmer solar corona, the atmosphere of the sun. And so in red, you can see one corona, and then there's one that measures the even dimmer corona further out from the sun that is the blue part of the image. So here you can see the sun is really active, and there's all sorts of explosions, these coronal mass ejections and solar flares going off.
So if we can make these fake eclipses with satellites, why do scientists care so much about studying the sun during a natural eclipse?
So there are two reasons. One is that because of the way we make coronagraphs, you can't get all the way down to the surface of the sun. You'll see there's this big black gap. And In a total solar eclipse, the moon is almost perfectly the size of the sun. And so we can see the solar corona right down to the surface where all the action is.
So can you tell us a little bit more about the different ways that the sun can impact us here on Earth?
So the sun gives off these large storms, what we call space weather, and they can affect our astronauts in space, our satellites in space, and can even affect us here on the ground. So it's very important to know the short-term and long-term changes in the sun because they do directly affect us here on Earth.
So these solar storms are also related to auroras, is that right?
So yes, the sun's input actually through a fairly complicated process, interaction with the Earth's magnetic field, is what causes the really gorgeous auroras around the North Pole and the South Pole. It's really tremendous. If you've never seen an aurora, that's another thing, like an eclipse. It's one of these natural events that's really stupendous.
Yeah, I really want to see them. I haven't yet. So, Eric, how about we step back here, and we're going to talk with Lika and Alex, and they're going to answer a few more questions that viewers have been leaving us. So I will hand this off to Lina.
Thanks, Sarah. If you're just joining in, my name is Lina Tran, and I'm another NASA science writer in our heliophysics division. I've got more of your questions for our scientists. So, Alex, first question is for you. If people can't be in this path of totality during August 2017, can they still see any of the eclipse?
Absolutely. So all of North America, all of Central America, portion of South America, Europe, Africa. I mean, a lot of different people across the country, probably more than 1 billion people, are going to be able to at least see a partial eclipse. So absolutely, you should go out and watch the partial eclipse, use the safety equipment that we talked about, and then you can watch live streams to see the total eclipse if you can't be in the path of totality.
Okay, great. Thanks, Alex. Lika, we have a question for you. You were talking earlier about what it feels like to be watching an eclipse. How much does the temperature normally drop by during that kind of thing?
Actually, it's a significant change that you feel the difference. It's of the order of 4 degrees Celsius drop in temperature, at the central point. This is the path of totality. And you can actually, we have enough information, right, of the trajectory and everything that we can actually figure out the temperature gradient in the partial region to the path of totality, something that we are working on, and we will put it on the web.
Cool, that's really exciting. Eric, one question for you. What's the difference between a partial solar eclipse and a total eclipse?
So it depends upon exactly how well the moon is aligned with the sun. The moon has to be perfectly aligned with the sun in order to be a total solar eclipse. And then you get partial solar eclipses before and after the totality. So when you're in this penumbra, this larger region of shadow, then you're seeing a partial solar eclipse, but only a narrow 100-mile wide region sees the total solar eclipse.
Okay. And I think we have time for one more question. Alex, are eclipses dangerous in any way?
No, eclipses are not dangerous. Now, certainly looking at the sun without protection is dangerous, except during the time of totality. And so you need to be very careful that you know when that is exactly. But otherwise, it's not dangerous. It's a spectacular event, and it's a unique opportunity to do science that we normally couldn't do.
Awesome. This is so exciting. If you have any more questions, please check out our new website, eclipse2017.nasa.gov, for more information. Here you go, Sarah.
Thanks. So as Lina said, there's lots of information on our website, and we'll also be answering more questions over the next day or so in the comments section. So keep leaving those down below, and we'll get you an answer. You can also follow us on Twitter at NASA Sun Earth for more information about the eclipse. And thank you all so much for joining us here, and have a great day.
Thank you. Bye.